All right, so let's continue on with this. And this I'm going to slow down a little bit on because, while I think that the first page was pretty straightforward, I mean, it's still new. The second part was a little bit trickier. The graphing was the exact same way. The asymptotes were a little bit different, but hopefully those were still pretty straightforward. But I know that you guys will struggle with that a little bit because you guys have struggled a lot with the shifting of graphs, and that's been a struggle for any algebra student typically. And then this last part, this is the simple rational functions. This gets pretty complicated, a little bit more, okay? So hopefully it won't be as bad as I think, but let's take this slow. So we have other rational functions that are going to look like this. So we're going to have a function over a function. So instead of it just being a number on top, now we have variable on top and we have variable on bottom. So this changes the way we do it. Now, there's a couple of principles here, but again, it's not about you remembering or memorizing how this works. You want to know conceptually why it is the way it is, especially the first one. The second one, a little bit different. That's going to be more of a memory thing, and that's going to be also reintroduced again in the next section in 8.3. So this first one, it says, when you have something where you have a variable on both sides, the vertical asymptote of the graph is the line x equals negative d over c. Now that may not make much sense to you, but essentially here's what we're talking about. We know that we're always going to get a vertical asymptote when our graph is undefined. Okay, so a vertical asymptote is when the bottom of a fraction is 0. So when we make this bottom 0, if you see cx plus d equals 0, you'll end up getting negative d over c. The way that I look at it and the way that I think you should do it is just set the bottom equal to 0 and figure out what it is. So getting right into this example, for that, we would set the bottom equal to 0 to figure out our vertical asymptote. The horizontal asymptote is going to be a over c. What that means is we're going to take the leading coefficients, the two numbers that are in front of our x's, and create a fraction, and that will be our horizontal asymptote. So let's do these one at a time. Let's start with the vertical asymptote. So our vertical asymptote here, and I'm going to label these so that way you can see it. Okay, so our vertical asymptote, I'm going to set the bottom equal to 0. Remember, a vertical asymptote is where we get an undefined, and that's where the bottom is equal to 0. So 4x minus 2, we add 2 to both sides, we get 4x equals 2. So we get x equals 1/2. So there's our vertical asymptote. Then we do our horizontal asymptote. So what we have here is, again, we're taking the leading coefficients. So it's just going to be y equals 2 over 4, which is also equal to 1/2. So we have y equals 1/2 is our horizontal asymptote. So now what I want you to do then is now we can graph. You always want to do your asymptotes first. Okay, so I'm going to do x equals 1/2. This is going to be a little bit tough because of the way the graph is scaled, but that's okay. So it'll be approximately right here. It doesn't have to be perfect. As long as we have the right idea, I'm not too worried about it. And then we have y equals 1/2, which is approximate. Oh, that's definitely not it. We don't want to be on the line. So that's approximately right here. Okay, so we have our horizontal and our vertical asymptote. Now we go through the problem the exact same way we did before. So the real tricky part is finding the asymptotes, and that's this entire section. So now the only thing we have left to do is figure out our points. And we do the same thing we did before. Pick 2 points to the left of our vertical asymptote and 2 points to the right. So the points that I picked were, I have -1 and 0. Okay, those are 2 points to the left. And then to the right, I picked 1 and I picked 2. So again, all I'm doing is plugging these values into this equation. We need to be able to do that. I mean, this is just substituting a value in and getting what the answer is. You should be able to do that. That is elementary type math. So I'm not going to go through that. I'm just going to give you the values that I got. And again, they're not always going to be pretty. It's what we get 1/6, negative 1/2. I got 3/2, 3/2, and I got 5/6. And again, if you have a major problem with fractions, you can always turn them into decimals. It's okay. So then what I do is I plot each one of these. I'll do the -1 and 0 first, and these get really close, but we have -1 and 1/6 is literally right, almost right on this line based on our scale. And then our other one is 0, comma, -1/2, which is right here. But notice, we still are not going to cross these asymptotes. It's just literally going to be a graph that hugs those lines almost all the way through. Okay, and then we do our other one. We have 1, comma, 1.5. So that will be somewhere around right here. And again, it doesn't have to be perfect, but as long as we get the general idea of this, then we're okay with it. And then 2 and 5/6 will be somewhere right around here. And again, we have another line that's going to hug our asymptotes. But again, it doesn't cross them. Okay? It approaches them in both directions, and then we have our hyperbola. So again, the only thing that's difficult about this is going through and finding your vertical and horizontal asymptotes, but it's the same process each time. So down below, go ahead and do that one on your own. Hit play when you're ready, and you'll have your answer and how we got it, and then we will be done. Okay, so this is the graph that you should see. Okay, again, asymptotes. You should have gotten a vertical asymptote of x equals -3 because we set x plus 3, the bottom, equal to 0, and then solved. And then our horizontal asymptote should be y equals 1 because the coefficients in front of the x's are both 1, so we have 1/1 equals 1. And then I just plotted points. So again, make sure the asymptotes are correct. Also, don't forget that these went by 2's, so if you mess that up, that's okay. Just make sure you understand that you probably did it right. You just you had to pay attention to the scale of the graph. But the asymptote here is at -3. The asymptote here is at 1. Plotted our graphs, and then we just connected them. And again, our graphs are approaching the asymptotes, but never touch them. So again, that is the section. I know it's the same concept all the way through, but there are 3 different types of graphs that we're dealing with. One is with a parent function with a number on top where the asymptotes are both 0. The next one was where we shifted our asymptotes, but the number was still on top. So we didn't have to really do much else except shift our asymptote. And then the last one was where we had variables on both top and bottom, and we had to figure out what our vertical asymptote was by setting the bottom equal to 0, and then our horizontal asymptote by the coefficient or the ratio of the coefficients of our leading terms. So hopefully that makes sense. Don't forget to take your quiz on Edmodo, and I will see you guys later.